Hello everyone, it's Hitesh here. So today the topic will be called as a data warehousing. Okay, so we will learn the different concepts here, like what is meant by data warehousing and what is meant by the OLAP server, and how the particular what type of approaches we follow in data warehousing. So what are the types of data warehousing we have, and how the architecture of data warehousing works. Okay, what are the steps we follow in order to do the functional and utilities of the data warehousing. So we will see all these particular concepts in today's session. So let's start with a concept of what is called as a data warehousing now. Right now, it is kind of a system, management system. You heard about that. There is also kind of called as a data management system, which manages the data very efficiently. So in that term only, data warehouses is kind of a management system only, through which it is designed to implement some business intelligence activities, and it's a process of constructing and using the data warehouses. So these data warehouses get constructed by integrating the data from the multiple and heterogeneous sources which support analytical, reporting, structured or ad hoc queries, and make the decision on the basis of all that functionalities. Okay, it involves various processes like integration, cleaning, consolidation, okay, transformation, and etc. So there are you can say decision support technologies which help to utilize the data available in data warehouses, and these particular technologies will going to help you the executive to use the warehouses quickly, effectively. Okay, now we will see what are the particular functions of data warehouses we have. Okay, the functions and the tools and utilities we use in data warehouses is called as a data extraction, which is the first one, which involves the gathering the data from the multiple heterogeneous sources, like we are gathering the data from the different from the databases, SQL Server databases, or we are gathering the data from the Excel. We are gathering the data from the different types of databases. Then we are gathering the data from the secondary sources or any primary sources. So that all the data just gathering, okay, from the multiple heterogeneous sources and kept into the one single place. And the next, after gathering that all the data, we have a next step called as a data cleaning, which involves finding and correcting the errors in the data. Suppose we have some missing values and we have some null values in the data. So in order to handle that missing and the null values, right, we have a concept called as a data cleaning. And third, we have a data transformation. Right, after cleaning the data, definitely we have to convert the data from one part to another part, or one format to another format. So in order to convert the data from legacy format to the warehouse format, we have a data transformation. Next, we have called as a data loading, which involves the sorting, then summarization or consolidating, checking the integrity, building the indices and the partitions. These all things including the data loading. Okay, next part, last, which is called as a data refreshing. Okay, in this data refreshing, what happens? Suppose now it involves the updating from the data sources to the warehouses, and data cleaning and data transformations are the important steps in improving the quality of the data and the data mining results. Now even if we see the architecture of the data warehouses, okay, perfectly, this is the complete architecture of data warehouses, which involves the process of query driven approach and the update driven approach, right, which is the integrating approaches of the data warehouses, which is the traditional approach to integrate the heterogeneous sources, which is followed by the query driven approach. And when query is issued to the client side, a metadata dictionary translates the query into an appropriate form for individual heterogeneous size involved, and this query driven approach are mapped and sent to the local query processor, which results from the heterogeneous size and integrated into global answer set. Okay, in update driven approach, which is an alternative to the traditional approach, and it is a modern approach actually, because now today's all the data warehouses system follow the update driven approach only, rather than going for the complexity of the query driven approach, right, because the information here from the multiple heterogeneous sources are integrated in advance and stored in some warehouses. So it provides the high performance, this update driven approach. The data is get copied, processed, integrated and annotated, and query processing does not require any kind of an interface to process the data at a local sources, right? So these are the some points which includes in the concepts of data warehouses. Now we will see the little bit understanding how the architecture works. Okay, now can you see here the data like databases like ERP, the mainframe, then after that we have a CRM, then flat files. So data from the different sources are gathering and placing into the extracting into the storage databases. Now here in this storage databases, it just tuning the production strategies, okay, where it can well tune this particular data and repositioning the particular data, managing the product portfolios by comparing the extracted data from the different domains, right? Next we have called as a transformation. Now if you see this particular transformation here in this, that just we have discussed like how the data has been converted from one format to another format, right? So in transformation process we mostly transform the data from one data or taking the data about the metadata repository or setting the data cubes into the multiple dimensions, right? Now after transformation of the data, it just process the one kind of a loading method which is called also as a delivery method or some methods, or also called as a delivery process, where the variant of joint application development approach adapted for the delivery of a data warehouses, which includes the you can say automation, and then it also includes the concept called normalization, and like extracting, loading the data, and backing up the data or achieving the particular data, right? So this type of concepts involves in the loading scenarios. Now let's come into the enterprise data warehouse system, where the business analysis framework has been get analyzed, right? Whether it gets the information from the data warehouses to measure the performance and make the critical adjustment in order to win over the other business holders in the market. So it also having some following advantages, like since the data warehouses can gather the information quickly and efficiently, it can enhance the business productivity, right? It provides a consistent view of customers and items, hence it helps the manage the customer relationship. It also helps in bringing the down the cost by tracking trends, patterns over long period in consistent reliable manner, right? So this particular enterprises warehouse system actually, or the you can say entire architecture consists of around four views called as a top down view, data source view, data warehouse view, and the business query view, okay, which also called as a bottom tier, middle tier, and the top tier approaches. Okay, in bottom tier of the architecture, you can see it is a relational database system which uses the backend tools and utilities to feed the data into bottom tier, and these backend tools and utilities perform the extract, clean, load, and refreshes functions. Middle tier include the you can say OLAP server. Okay, it includes the OLAP server. OLAP is nothing but it's an analytical online analytical processing server, where it is kind of an you can say extended relational database management system which maps the operations of the multi-dimensional data to the standard relational operations. And we have two types of OLAPs here. One is called as relational OLAP and one is called as a multi-dimensional OLAP, which is also called as ROLAP and MOLAP, which directly implement the multi-dimensional data and the operations. Last tier we have called as a top tier. In top tier, what happened? It's a kind of a front end client layer which holds the query tools, reporting tools, or analysis tools, or data mining tools, like this, all the things. Now it's also having some you can say models. Data warehouse is some kind of a models which is called as a virtual warehouse, data mart, and the enterprise warehouses. So virtual warehouse, where it is view over an operational data warehouses, okay, where it is easy to build a virtual warehouse because it requires the access capacity on the operational database servers. Second is model is what called as a data mart, where it contains the subset of the organization's data or organization's wide data, you can say, where the subset of data is valuable to specific groups of an organization only. So we can claim that the data must contain some data specific to particular group. Okay, and the marketing data is also related to items, customers, sales, or any other specific domain you can talk about. Okay, next at last we have called as an enterprise warehouses, where It collects all the informations and the subjects spanning an entire organization, which provides us enterprise-wide data integration and is integrated from operational system external information providers. Right. And these types of particular enterprise warehouses operations can be done where the information can be few from gigabytes to the hundreds of gigabytes or terabytes or beyond the data can be stored. Okay. It also includes the load manager or the which performs the operation required to extract and load the process, and it also having the simple transformation process which is required to perform some simple transformation like doing the position checks and the complex checks whether that particular query has been getting wrong or not. Okay, stripping out all the columns which are not required within the warehouses. So this type of operations can be performed in the transformation. Okay, so this is all about the data warehouse architecture. Next, come to the OLAP serve process now. Now this OLAP process, which is also called as online analytical processing, right? This include the middle tier which we have discussed now, and in this middle tier, this online analytical processing server is based on the multi-dimensional data model, which allow the managers and analysts to get an insight of the information through fast, consistent, and interactive access to the information. Okay, so there are basically just we have talked about the types of OLAP servers, right? We have talked about around two types of OLAP server, which is called as a MOLAP and ROLAP, that is multi-dimensional OLAP and the relational OLAP. We also have two other OLAPs, which is called as a specialized OLAP server, and one is called as a hybrid OLAP server, which is also called as OLAP. Okay, and relational OLAP, what happens? It is placed between the relational backend server and client front-end tools. So to store and manage the warehouse data, ROLAP uses the relational and extended relational database management system, which implement the aggregation, navigational logic, or optimization for each database management system backend, additional tools and services. These things. Multi-dimensional OLAP you can say as an array-based multi-dimensional, which where the engines for the multi-dimensional views of the data has been stored in the MOLAP. Okay, and with the multi-dimensional data stores, the storage utilization may be low, but if the data is sparse, therefore you can say many MOLAP server uses the two levels of data storage representation only to handle the dense data in these sparse data sets. Hybrid, you can talk about the combination of ROLAP and MOLAP, which offers the highest scalability of ROLAP and faster computation of MOLAP. So most of the data warehouses is based on the hybrid type of concepts only. Okay, it uses the hybrid OLAP architecture, where it allows to store the large data volumes of detailed information with the aggregation and navigation logic, and simplify that all the logics in order to separately store the data into different combination of the servers. At last, which we have discussed, that is called as specialized or SQL servers, right? It is provide the advanced query language in order to deal with that amount of gigabytes or terabyte or petabytes of the data, and it process the particular queries over the star and slow fix schemas in a read-only environment, right? Now next is called OLAP queue. The OLAP queues has been represented by the OLAP operations, where the OLAP servers are based on a multi-dimensional view of data. Okay, some OLAP operation and the OLAP cube operations you can talk about called as a roll-up, drill down, slice and dice, and a pivot. Now roll-up, you can say it performs an aggregation on the data cube, and by climbing up the concept of the hierarchy for any dimension or any dimension reduction, and it also performs some climbing up the concept hierarchy for the dimension location. Like suppose the hierarchy can be state, city, province and country, like this. Okay, so on rolling up, the data is get aggregated by sending the location hierarchy from the level of city to the level of country, like in this way. Like just I have written here: Phoenix, New York, Chicago and Los Angeles. Grape, strawberry, cherry and mango. Nice. So you can see this is a kind of an hierarchy here. Next we have a call as a drill down. Drill down actually is the reverse process of reverse operation of the drill down. Means this you can say concepts of roll up. Roll up will going to do the some kind of ascending, means increasing the level. Then definitely drill down will going to decrease the level. It means stepping down the concept of hierarchy, like Los Angeles, Chicago, New York and Phoenix, in this way. Okay. Third, we have a slice and dice, which slice operation which select one particular dimensional from any given cube and provides the new set of cubes, and dice will going to select the 2 or more dimensions from the given cube. Right, if I am selecting in a slice, like I have to select only phoenix, which showing the around $5,000. But if I wanted to select the phoenix and mango, right, both the 2 dimensions, then that can be a dice one. Right, and last we have a call as a pivot, which operation which is also known as a rotation approach. Okay, can you see the q4, q3, q2, q1, the time dimension, category dimension? This can be, the cube can be rotated. Okay, means we rotate the data access in a view to provide some alternative presentation of our data. Right, so Chicago, New York, this Phoenix, New York, Chicago, and Los Angeles can be rotated to the time dimension area, and the time dimension can be rotated to the category dimension area. Okay, now I've given you the all the, you can say, working of the OLAP. How the OLAP cube works by using the 4 operations called as roll up, then slice and dice. Then after that we have a particular call as drill down, and at last we have pivot, which is called as a rotation. Next we have called as an OLAP versus OLTP. Okay, see now the difference between OLAP and OLTP. We have discussed about the OLAP. Now what is OLTP? Just like OLAP, we have a OLTP, which is called as an online transaction process protocol. Okay, which involves the concepts of, you can say, operational databases, right, which involves day-to-day processing. Because see, OLAP will going to involve the historical process of information on the basis of historical data, but OLTP will going to involve day-to-day processing. Okay, OLAP system will going to use some by knowledge workers such as executive, manager, or analyst, but OLTP systems will have to be handled by the DBAs or the database professionals. So OLAP will going to use for the analyzing the businesses, or OLTP, you can say, it is useful in running the businesses. So there is a differences between analyzing the businesses and running the businesses, right? The data information means information out is focused by the OLAP, and information in is focused by the OLTP. So various types of schema is also present in OLAP, like stars schema, snowflake schema. Okay, you can say fact constellation schema. But OLTP is directly based on the one model called as ER model, which is called as an entity relationship model. Okay, and so there are many vast differences between this OLAP and OLTP, which can't be covered in just one session. Okay, now if you wanted to learn in deep, or you wanted to explore more about the data warehousing concepts, how the particular data warehousing concepts helps in the data analysis, and how the big data analytics and other analytics domains work with the data warehouses. Okay, you can connect to the Coachx.Live. Definitely they will going to guide you at the best level. So guys, do subscribe and do the comments on the channel. So for today, this much is okay. I'll come again with a new topic tomorrow. Till then, bye bye. Take care, guys, all of you.